Okay, this is transmission scope capturing part one. We're basically gonna scope capture different components of the transmission as it goes through its shift. It's basically going to be a run from a dead stop at a stop sign to about 70 miles an hour. It's a 5-speed automatic on a 2.4 2004 Honda Accord. It has a lockup torque converter and overdrive, and we're going to concentrate on the shift solenoids. I will show you an illustration of everything, and you can it's best that you take a snapshot of it and kind of watch it as we roll through the scope captures to make it a lot easier. Anyway, I will go to our illustration and talk about it. Obviously, you can see our illustration in front of you. That is our schematic, and let me get a better. Okay, you can see the schematic in front of you, right here. Okay, basically we're gonna be on 8 channels. This transmission has 5 shift solenoids and 3 pressure control solenoids. Shift solenoid A through E and pressure control solenoid A, B, and C. It has an input speed sensor, as you can see. It has an output speed sensor. It has many other components. I just want to, in this scope capture, we're going to watch the 5 shift solenoids through the shifting from standstill till full lockup and high speed. That would be 5th gear. And we're going to current ramp the 5 solenoids, shift solenoid A through E. We're going to coordinate the colors to the pico. Obviously, shift solenoid A would be blue, shift solenoid B red, shift solenoid C green, shift solenoid D yellow, and shift solenoid E would be purple. Our other channels, channel F is our input speed sensor. Channel G is our output speed sensor. There's the input speed sensor. Input speed sensor I want to talk about a little bit. In pretty much every transmission, it is going to somewhat mimic the crank speed, the engine rotation. Not 100%. There are variables there. It's kind of like watching a tachometer when you drive a car. The tach goes up, the tach goes down as the car takes a shift. And it's going to be like that on our scope capture. And we'll kind of key in on frequencies and RPMs and show the way it looks on the scope. Output speed sensor is different. It's more linear. It is more like the speedometer on the car. It's going to just pretty much go as the car goes down the road and puts output in frequency. These are 5 volts. I believe they're magnetoresistive or Hall effect type square wave signals. And they'll be on the scope. Channel H, burgundy, I have a 500 PSI transducer into a line pressure tap. Now this transmission has many different taps for different situations, first clutch, second clutch, third clutch. I'm at the main line pressure tap. And the thing I want you to notice is that every time a transmission, the tranny takes a shift, it goes 1 to 2, 2 to 3, and so on. The line pressure is affected. We're going to see that on the scope pattern. So basically what I did, I have a 500 PSI transducer hooked into the line pressure tap, fairly easy to get to in the lower front of the transmission. And I will go over and I'll show you that transducer, what that looks like. This is what I call a transducer that does the dirty work. It's not pricey, maybe about $15 on eBay. It is a 0 to 500 PSI transducer. I had this piece over here to the left, that adapter I had to get online in a tranny supply place. Just be mindful if you ever use something like this, when you pull the plug out of the transmission, the plug on the vehicle, there's that little aluminum washer. You want to reuse that aluminum washer right with this guy right here, right there. You want to reuse that. Yeah, just for the test. And then when you go back in, put the plug and the aluminum washer back in when you're done, because that's really important as far as leak prevention. The elbow I had to use, sometimes you'd have to use this when you check pressures on transmission, because there's angles and room is tight. So I actually had to put the transducer through the top, hooking it to the scope. On the actual part of the transducer that I built, there's a 9-volt regulator, and you see the 2 banana leads right there. The transducer comes with a pigtail right there, and you build this transducer. Basically, it's the pigtail has the 3 colors, has a red, a blue, and a ground. And the 9-volt regulator is right here. I use a 9-volt battery as a 5-volt regulator with an output of 5 volts and a ground. And basically I hooked that into the vehicle, got in, so I was able to get the line pressure hooked up. I have custom probed the scope to read PSI, and so we're gonna look at that. And I just want to talk about a few other things. Shift solenoids are devices, as you can see on the illustration, the transmission pump. The red going into the pump obviously is transmission fluid. The pump will output its pressure. The shift solenoids will actually latch and send pressure to the clutches. They actually do it through a regular shift valve. I just didn't want to make the illustration too complex, but the idea is that a shift solenoid actually moves and sends oil up to a clutch to apply and then create an upshift or a downshift. So that's there are 5 of them, and you can see shift solenoid A, shift solenoid B, shift solenoid C, D, and E. And the 3 other things, the pressure control solenoids, I will show them in a part 2 video. They are duty cycled by the PCM to control pressure, and I'll leave it at that. I'm not a transmission guru. Just be mindful that they actually have more of a fine-tuned control of the amount of pressure, where shift solenoids route it's the direction of the pressure. So let's go to the scope, and we'll see. This has been recorded, and we're in we see on the screen. We'll talk about each channel. Channel A through E are shift solenoids, and they will have a distinct look to them when the transmission shifts. We will verify a pintle hump, because that's real important. I opted to use current clamps instead of looking at voltage, because either way the current clamp proves that the PCM carried out a command, and the current clamp gives us more of a validation that the solenoid actually physically moved, as detected by the pintle hump. We have 2 speed signals. Gray is the input speed, orange is the actual output speed. That's when the car starts to actual move. This is when the car's in park and idling. You will see you will see an input shaft speed, as in most automatic transmissions. So we're on 1 of 12. Right here is where I actually started the car. We'll look at pressure first, and pressure kind of okay, this is our pressure, and it climbed pretty quick, and it got to about looks about 131 psi. So here we go. We'll go through. It's going to get a little congested. I'll try to explain everything. We'll break each component down and talk about it. And there's one more thing which I failed to show you, which I will show you right now. I'm going to get away from the scope. Follow me here and take a picture of this also. This is real important. This is a shift solenoid chart, and I will explain this. There on the top of the 5 shift solenoids, A, B, C, D, and E, and then we have the gears, that the position of the solenoid when they get into a gear. I got this right out of Honda service information. Just something to be mindful of. You'll probably see it in the scope patterns. Shift solenoids. These are the conditions of the shift solenoid when they're actually in that gear. Going from like first to second, a shift solenoid may behave a little different. So I didn't want to add that to make it too confusing. So basically, we may see that on the scope, and I'll try to bring that out when I have the pattern running on the scope. When we look at the shift solenoids when they apply and they release. Anyway, take a look at shift solenoid E. The conditions don't say specifically on. It could be on or off. It doesn't say specifically one or the other. And something tells me that has something to do with a lockup torque converter. Honda doesn't have a designated torque converter clutch solenoid like other manufacturers, but in reading service information, shift solenoid E is very much paramount as to the condition of the lockup, if the torque converter is locked up or unlocked. So just bear that in mind. Please print this out. I'll be using it during the demonstration. I'll have to grab it because each shift to validate where everything is and everything should corroborate as we go through the first to fifth going down the road. One more thing to be mindful of is take a look at these guys. These are inputs. We're not going to be scoping them, but nonetheless, you never want to. I'll go through each one and talk about it. A lot of these inputs are very important to where the tranny shift. They're just as important to the engine performance as they are to the transmission performance. The top one is electronic throttle control. This car does not have electronic throttle control, but other cars may. There are times when a PCM may determine that a transmission is in trouble by its input and its output speed. It's inferring that there's slippage. It will shut the throttle down. So if you ever get a throttle code, don't be so tunnel visioned into the electronic throttle control motor, because it could be a result of the PCM shutting the throttle down to protect the transmission. TPS, map, RPM, brake switch, and mass air, all vitally important inputs. Brake switch, I guess more so for lockup, because the brake switch should hang low or open up going down the road. It will take the torque converter clutch out, meaning it will disengage. Mass airflow, obviously this is a speed density car, but nonetheless, mass airflow is a really important input to the performance of the transmission. I've heard stories where a dirty mass airflow has smoked some GM transmissions, so be mindful of that. Let's go to the screen and go through the looks like we got 12 screens in this movie, and we'll take a look at each. As you can see, we are in let me give some stretch. I want to give some stretch to the each of the solenoids, and we'll talk about each one as we go. I will grab that solenoid paper because I need to read it while we go through each situation. This is the first capture. The car is just starting up, and let's take notice of our situation. First thing I just want to talk about is input shaft speed. See what that looks like. That basically is that's right here. That's the input shaft speed, and that is something the PCM is a high priority input to the PCM to determine the shift. So right here is right here, the car is starting up. It starts to roll right here because our output is orange. Okay, you see it right here. Okay, that's our output shaft speed. That means the powertrain is actually moving. So we know that. And let's talk about first gear and what happens in first gear as you look at your shift solenoid chart. Let's take a look at first gear and shift solenoid A. Shift solenoid A blue is, I'm going to say on. That's right here. That's shift solenoid A is on. Okay, shift solenoid B red is on. Okay, let's look at it. First of all, let's get an idea of the amperage of these solenoids. I'm going to say I have tested a lot of them. They're about 730 milliamps they draw. So that's on. Let's see what red is drawing. Okay, that's about 746 milliamps. Green is on, as our chart says. We got the first three on in first gear. So we see that. Green is on 704 milliamps. Our transmission pressure is about 134. Shift solenoid D, yellow, is off. As we can see right here, we are off. And let's see what off is. That's a micro probe, so it's not, yeah. That I can tell you is very little amperage. That solenoid in yellow, as you can see, is off. Purple solenoid, shift solenoid E, is off, as our chart says. Look at your chart, and this is purple. This is solenoid P, solenoid E, purple, and that is off. It doesn't have the normal 700 milliamps as the others that were on do. So this is gear one, and one thing I want to do, I want to get an idea of speed. So I'm going to kind of make a little test of our orange channel. Okay, that is, I want to create a measurement of that because we want to see that change as we go through. We add a measurement. We're going to go to here. We want to go to channel 7. We want to go to frequency, and we want to go to between the captures, between rulers. Okay. So let's take a look at our frequency. That may give us RPM too. Okay, get back. Okay. Okay, we got about 1.7 hertz. That's not that's 1.7 hertz. That's in this capture. Let me go here. Okay. Okay. Okay, we got 12.93 hertz. We got about 770 revolutions per minute. That is of the output shaft of the transmission, mind you. So remember, let's keep an eye on that. 775 right now. That's in first gear. Let's go back to our next upshift. Okay, look at your chart. We're going to go to second gear. So second gear, the blue guy is off. So that's about right here. I guess this would be second gear. Let's take a look. Blue is off. Red is on. Let's look at red. No, we're not quite, that isn't quite the two shift. Let's see, we may have to go down here. Okay, this would be, I'm gonna kind of call this second gear right here. Our blue is off, as it says, right? So we have a low amperage, that is off. Red is on. Let's go to red and look at this being on, right? We got our 700 milliamps, okay. C green is off, that should be low, and it is low, yeah. D yellow is on. So let's kind of look at yellow, and we're going to look at that, and okay, now this is, yeah, we got a conversion attenuate, yeah, millivolts is basically milliamps on that clamp, so yellow is on. That's about 726 milliamps, and that is second gear right there. Let's take a look at our speed, if we can get if we can go higher, because we know we're moving down the road faster. We go to measurements, we go to add measurement, we want to look at frequency, channel 7, frequency, hold trace between the rulers, okay, here to here should be higher. Oh, no. Okay, we're going up. Look about 1,888 RPM, 31.47 hertz. So that makes sense because we're going down the road and our output shaft is turning faster. Okay, let's keep going. Let's get back to get the zoom out. And where's our pressure? One thing to make note of, and this is why I added the pressure transducer. Take a look at the pressure every time a shift happens. That's not coincidence, that's not happenstance, and that's not some anomaly. There's a direct correlation between pressure and a tranny taking a shift, because there's a dynamic change. You have a oil that's got to feed a clutch through a shift solenoid. So just bear that in mind, that you'll see that throughout this presentation. Look at the green is lining up perfect with the pressure drop. It took a little volume hit and probably dropped the pressure, very little, but nonetheless, I would call that like a volume drop right there. You see that right there? That and the shift, that's definitely a relationship there. There's something to bear in mind. We'll see that again as we keep moving down the line to the next gear. Where are we now? We're in third gear, where blue and red are off. And let's kind of get to that. I'm going to call this third gear, and maybe the egg's not on my face. Blue should be off, right? Blue is off. Red is off, right. Third gear, red off. C Charlie, green is on. So we should see a 700 millivolt here, and we do. Milliamp, yes, that is right. That is on. Keep an eye on your sheet. D yellow is off. Let's roll this down to yellow. And we're seeing minutia, very low. That channel, that solenoid is off. Channel channel E, purple should be off. Let's take a look. And it's definitely low. Okay. Okay, maybe we had a little trouble zeroing that one. But nonetheless, it is off. I'll take a look at. Let me roll back to see what that looks like when it's on. Okay, so we're going to go up to our next gear. We're in. Okay, so this would be our fourth gear. Fourth gear is blue is on. You see that. Red is off. Let's see that. Okay, low. Green is, fourth gear is off. Makes sense. Let's roll this guy down to here. That is off. Okay, yellow is off. Okay, right, that is off. That is low. And purple, let's take a look at purple, is supposed to be off. Let's see what she looks like. Okay, I might have had some color clash issues before. That was my bad. Purple, right, is very low. That's not 700 milliamps. That's kind of like, that's low. That's current not flowing. And again, let me do some vertical zoom on our pressure to make it stick out. So look at that. You can see the pressure drop, and when it took a shift, right in line with blue. So that tells us the advantage of looking at pressure. Just to point that out. Okay, we'll go down the line. Let's go to our final situation. That is fifth gear. And in fifth gear, let's see what happens in fifth. Blue is on. Let's see blue. Makes sense. Blue is on. What is red in fifth gear? Okay, red is off. Keep your eye on your chart. Everything will make sense. Okay, that's low. Fifth, red is off. The current's not flowing through that solenoid. See, the green is on. We should see 700 milliamps. And we do. Okay, we see about 733. Okay, D, the yellow is on. Let's see what we get here. We should see, okay, yeah, there it is, about 730. That's millivolts equals milliamps for that probe. How about purple, fifth? Now this is the one that says on or off. This is our probably our lockup that has more of an effect on lockup. So let's look at that. That looks like it's on there. Okay, that right there. I'll look at purple, and that is on. Okay, so we can probably say that the torque converter is locked up at this point. If I just touched the brake pedal when I did this, it would probably go down. But nonetheless, as I said, there's no specific TCC solenoid on the Honda. They don't call it something, but it definitely uses the shift solenoid E to lock the torque converter up. Now we look like we're kind of decelerating. You can see the difference. You see the blue change. You see the purple change. Now, when I was telling you about that situation where sometimes solenoids do things between shifts, they act in a different state from they are when they actually get to the gear and stay there. That I see that in purple here. Obviously, our pressure is right in sync with our blue and our yellow. You can see that right there. That it's starting to downshift, and it's pretty much clear. And one thing I want to talk about, I didn't talk about yet. I will go back and I'll pick I guess I can pick any spot. That's pintle humps. Let's take a look right here. Let's take a look at blue, and we'll verify that the condition of our solenoid. I'll zoom in on this, and you will see something that's pretty cool right here. Right here. Okay, right, that's not I'll probably get a better shot for you. That is a pintle hump. You can see that. I've checked all these, and this is okay. I want to get a better one for you to see what they look like. That's just Okay. Well, there was some shifting there. We can tell by the pressure. Go blue. Right there, you can see that pintle hump right there. That's a pretty good depiction of it. That's a validation that solenoid physically moves, so it has real good diagnostic value when you're diagnosing a shifting issue. Let's see what red looks like. Red's pintle hump. Okay, there you go. That's another one too. That's a pintle hump right there. You can see that. They all have it. I checked them. The video's getting kind of long. I hope you guys enjoyed it. Craig Shippey and Gary and the guys. I know you're tranny guys, and I'm no tranny guru, but nonetheless, this is a good way to look at things when you have tranny troubles. Doesn't substitute for a scan tool. Scan tools are real good. They have good graphing capabilities these days, but this is, you know, being a direct quantitative measure of things. And don't forget your inputs. You had on your sheet the throttle, the TPS, the map, the RPM, the brake switch, and the mass airflow. I'm going to sign off, and thanks for watching, and take care. Bye-bye.